Hi, kids. We are gonna do a couple just practice little problems dealing with Newton's second law, and then you guys are gonna practice some stuff and take some notes over it. On, I think it's I don't know. It's called Newton's second law, but in your packet. All right. So, um, first of all, I want to make sure you guys understand that Newton's second law is easy if you allow it to be easy. So let's pretend these are completely different set problems, but let's pretend you drew your force diagram on an object and you had 10 newtons this way, 15 newtons this way, and 5 newtons this way. Okay, that here's what you are going to do. You are going to go, well, okay, if I wanted to find the net force and I wanted, hopefully you, in this case, you would go, well, the net force is going to be 20 to the right because this is easy. Well, I want you to think, how would you have written an equation that shows that? And you would have said, well, it would have been 10 plus 15 minus 5. Why 10 plus 15? Because they're going the same way. So like your F net equation would be 10 newtons plus 15 newtons minus 5 newtons. Okay, and then you would get your net force of 20 newtons pointing to the right. Okay, if you had an example like this, let's say you had an example where you have an object and there's forces, there's a 5 Newton force down, there's an 8 Newton force down, and then there's a 3 Newton force up. What would you do? Well, it would be 5 plus 8 minus 3. And then you would get your answer, which would be, so it would be 5 plus 8 minus 3, and that would equal 5 newtons pointing down, okay? It's that easy. Don't make it harder than that, okay? So your first step is going to be to draw your FPD, and then after you draw your FPD, write your equation from your picture, and then you solve stuff. So let's do this problem, and this is similar to the problem that you'll see in your packet. We have 3 students, Aman, Joe, and Juanita, are pushing a car against friction. So, and you actually, by the way, hopefully, if we're at school, you guys are going to do a lab with this where you're going to be pushing your teacher's car. The car speeds up. The Aman pushes with a force of 100 newtons, Joe 80 newtons, Juanita 90 newtons. I should probably tell you what friction is acting, so let me do that. So I need that. The force of friction is going to be 60 newtons. So F equals 60 newtons. And then if the car accelerates at this rate, what is the car's mass? So, okay, here's what you're going to do first. You first are going to draw your force diagram for the car. So here is my car. Yes, my car is kind of boxy. Okay, but the point is, if you want to draw a box and draw the forces acting on the box, that's fine. If you'd rather just draw a dot and draw the forces acting on the dot, I don't really care. Okay, either way is totally fine. But if we are doing the forces that are acting on the car, well, I have the force of gravity acting on the car. I have the force of the ground acting on the car. Those two forces are going to cancel out. I have 3 of the students pushing. Let's say the students are pushing the car to the, I don't know, the right. So you would have the force from Aman. You would have, I guess, force of Joe is a little bit smaller. You would have the force from Joe, and then the force from Juanita. Okay? And then you would have the force of friction, and the force of friction would be going this way. So that's what your FPD, your force diagram, would look something like that. Okay, then your next step, and again, when you're writing your force diagram, you are always going to put variables. You're not going to put numbers on this, okay? Why are we doing it this way? Because this is what the College Board expects, and we're going to get used to doing what the College Board expects. So variables first, and then we're going to use this picture to write our equation. Well, I don't have to worry about these forces because they're going to cancel out. Eventually, we're going to start doing problems where you're going to have to write a perpendicular force equation. But for right now, we don't have to worry about it because they're going to cancel out. So then I would say, well, I have this force, and this force, and this force, and this force. Okay, so if I want to write my force equation, Well, it would be this plus this plus this. Why? Because they're pointing the same way. Minus this equals my net force. So my net force equals the force of Oman plus the force of Joe plus the force of Juanita minus the force of friction. Okay? Now, F net also equals, okay, we know from our Newton's second law that F net equals ma. So we also know that this equals ma. Now, if you are a student that you're like, oh, there's too many equal signs, I don't like that, well then just erase this, okay? Do we always have to write it equal to ma? No, because sometimes the question might say, what is the net force acting? Well, then just solve for the net force, okay? But in this case, because I'm asking for the m, we'll write it this way, okay? Or if you want to have both equal signs, but if that confuses you, then just erase the one, okay? So step 1, step 2, and then step 3 is finally plug our numbers in. So this is going to be 100 plus 80 minus 90, plus 90, haha, because they're going the same way, minus 60 equals m, which I'm looking for, times 0.1, and then you can very easily solve for m. So 100 plus 170 minus 60 is 210 divided by 0.1 is going to be 2,100 kilograms. That's a fairly massive car. So there you go. I hope that makes sense. Bye, kids!